am Jenny from IT department. For this semester, I have allotted to CS3451 Introduction to Operating System for second year IT students. Course outcomes. At the end of the semester, students can able to understand the various schedule algorithms and process synchronization. Some major scheduling algorithms include first come first serve, shortest job first, priority scheduling, round robin scheduling, multi-level queue scheduling, multi-level feedback queue. So course outcome 2, analyze and contrast deadlock prevention and avoidance algorithms. Deadlock occurs when a set of processes are blocked, wherever because each process is holding a resources and wait for another resources held by another process. So need to for necessary condition for mutual exclusion hold on by no preemption circular wait. Then course outcome 3, compare and contrast various memory management schemes. So various memory management schemes are strategies used by the operating system to organize and control random access memory so that multiple programs can run safely and efficiently at the same time. So for course outcome 4, understand the functionality of file system, I/O system and virtualization. So understand the functionality of file systems, I/O system and virtualization. So for fifth course outcome is compare iOS and Android operating system. Operating system comparing Android and iOS operating system. Then syllabus covered. First unit 1 introduction. So introduction 1 covers operating system overview, objectives and function, evolution of operating system structures, operating system services, system calls. All these topic is covered in the introduction part. Unit 2, process management. So process management including process concept, process scheduling, operations on process, CPU scheduling, scheduling criteria, scheduling algorithms, threads, multi-threads, semaphores, deadlock prevention, deadlock avoidance. All these covered in the unit 2. Then comes to unit 3, memory management. Memory management includes main memory, swapping, paging, page table, segmentation, page replacement. So all this covered in the memory management. Then unit 4, storage management. Storage management, file system interface, file concept, access method, directory structure, file sharing and protection, I/O systems. So all these covered in the file storage management. So how to giving file creation, deletion, directory management, file access manipulation, file naming. So all this in the storage management unit 4. Then unit 5, compare iOS and Android operating system. iOS is Apple designs the phone and the rules. Android Google provides the system. Many companies build phones. So now the topic is operating system. Come to the topic, what is operating system? An operating system is an interface between a computer user and computer hardware. An operating system is a system software which performs all the basic tasks like file management, memory management, process management, handling input and output, controlling peripheral devices such as disk drives and printers. Then examples. Some popular operating systems are, few most popular operating systems are Windows, Linux operating system, Mac OS, iOS and Android. Then operating system functions. Some important functions of an operating system is process management. So process management, input output device management, file management, network management, main memory management, secondary storage management, security management, command interpreter system, coordination between other software and users. So first function is process management. So process, what is process means? It deals, an operating system deals with how programs run on a computer. So process means process is a program in execution. A process is a program that is currently running. Example, WhatsApp running. Process management is the operating system responsibility to create process, schedule them on the CPU, synchronize them, terminate them properly, process states. So like a new state. A new state means now the being created, and ready state for waiting for the CPU. Running means executing on CPU. Waiting means blocked for waiting for input output. Terminator, once completed the process, it's finished, execution finished, that is terminator. The next function is IO device management. IO device management is a function of the operating system that controls all input output devices of a computer. Devices include a keyboard, mouse, monitor, printer, scanner. Then next function is file management. File management, first what is file? So file is a collection of data stored in a secondary storage. Example, document, image, program, audio, video. So file management is a function of operating system that helps file creation, deletion. So giving file name and file types, file operation like open, read, write, close, rename, file protection and security. Then file sharing. Network management is the function of an operating system. File sharing. So next function is network management. So network management function is network connections and allows computers to store data, files, printers and other resources safely. Network management handles data sharing, communication, security and connection management between a computer. So next function is main memory management. Main memory is a random access memory. It's a primary working area of a computer where programs are loaded, data is processed, CPU access information directly. So main memory management is the operating system function that keep track of which parts of memory are in use, protects memory from illegal access, optimizes memory utilization. Then memory allocation. Operating system decides how memory is given to the process. Then memory deallocation. Free memory when a process finish and give the memory protection. Then next function is secondary storage management. Secondary storage management is a non-volatile memory used for long-term data storage. So example, hard disk drives, USB drives, memory cards. Secondary storage management operating system functions that organize data on disk, allocates and free disk space, optimize access the ensures data reliability and safety. Then coordination between other software and users. So coordination between other software and users means connect users with the computer system. Coordinates applications software, system software and hardware. So coordination all these software, system software, application software and hardware. Operating system ensures everything works smoothly, safety. Then coordinator between users, human interaction. Application software, that means browser, editors, games. System software, compilers, hardware, CPU, drives, so on. So all these are functions of operating system. Then next concept is thread. So thread is a lightweight process and it's a basic unit of a CPU utilization. So thread is a lightweight part of a process that can run task independently. Process can have multiple threads all doing different tasks at the same time. For example, thread 1 consider a Google Chrome, for example. Thread 2, one thread loads a web page, another thread plays a video. So one thread handles user typing, one thread downloads files. Then the threads dividing an application, a program into multiple sequential threads that can run parallel, which makes the programming model become simpler. Thread has the ability to share an address space and all its data among themselves. The threads are lightweight process, but they are faster to create and destroy than process. It's the lightweight process, even it can fast to create, delete, and end of the process. Then types of thread. Threads are usually two types. One is user level thread, another one is kernel level thread. So in diagram, it's the one is the process. So process, it's one is user level thread and another one is kernel level thread. User level thread is a type of thread that is not created using system calls. Kernel has no work within a management of user level threads. User level threads can be easily implemented by the user. The user level thread, these are threads management by the user level library, not by the operating system. Then kernel level thread. Kernel level threads can take advantage of multiple CPUs or cores to the improve performance. To improve performance, take the advantage of multiple CPUs. Kernel level threads are managed directly by the operating system. It handled the operating system directly, whereas the threads management is done by the kernel. Each kernel level thread is not its own context, including information about the thread status such as name, group, and priority. Then thread states. There are 4 different states of thread: new state, ready state, running, blocked, and terminator. So new state is a thread is a new state or creation. So thread is being just born, memory allocated, but not yet started. Then ready states, ready or runnable, ready to run, waiting in a queue for CPU time. Then running, currently executing. So currently executing, it's happening currently executing instruction on the CPU. Next, blocked, waiting for an external like input output system. Terminated, so execution finished. Then multi-threading. Multi-threading means multiple threads running together. For example, one thread plays music, another thread downloads file, and one thread runs WhatsApp. All this happens together, so the phone feels fast. It's happening together, all the work is doing, but phone or system feels fast. So multi-threading is the ability of a CPU program to run multiple threads at the same time. The multiprocessing may be divided into process into multiple threads. For example, in a browser, multiple tabs can be different threads. Like that, we are working MS Word. So one is formatting the text. We are format the text. One is another thread to spelling mistake. So correction like this. So each one doing some work. Then multi-threading allows multiple threads, lightweight processes, to share the same resources of single process such as the CPU, memory, and I/O devices. Then single thread and multiple thread. Single thread is the smallest unit of a program. Multi-threading is the multiple threads running together. For example, one thread plays the music, another thread downloads the file, and another one runs WhatsApp. So all this happens together, so the phone feels fast. Then summary of the class, definition of operating system. Operating system is an interface between computer user and computer hardware. It is a system software, performs some memory management, file management like. Then functions of operating system. Functions of operating system is different functions we have. That is process management, then I/O device management, file management, network management, main memory management, so command interpreter system, so like this. Then thread and its type. Threads having two types, kernel level thread and kernel level thread. Thread states, there are different states, running state, blocked, terminator, so like this. Then multi-threading. So multi-threading means multiple threads running together. So this multi-threading. Single thread with multiple thread means a single thread is the smallest unit of a program. Multi-threading is the ability of a CPU or a program to run multiple threads at the same time. Thank you.